Now using 360 degrees for a full rotation, okay, may seem natural, but if you think about it for a second, it's not. 360 is kind of arbitrary. There might be like two good reasons why we kept 360 or that we use 360. There are 365 days in the year, so that's pretty close to how many days there are in the year. So that could be where that number is coming from. And 360, you can divide it in a lot of different numbers. So if you want to consider a 1/6 of a rotation or 1/12 of a rotation, that's going to give you a nice integer in degrees. So that could be a reason for using 360 degrees for a full rotation. But of course, if you meet an alien, there's no reason why that alien would use 360 degrees for a full rotation. So there's probably a more natural way of coming up with a measurement for radians that you might share with that alien, assuming that that alien comes from an advanced civilization. And it's linked to the concept of radians. So there's actually different ways to measure angles. Okay, so maybe I'll show you maybe two kind of natural ways of measuring angles. So imagine I have a circle here. Okay, and maybe I'll create, an angle by generating like here two rays. Okay, actually I chose two rays that don't actually start. Well, they start at the origin, but none of them are the x or the y axis. And this is the angle I'm looking at. Okay, how would I measure this in some more natural way? I could look at this point and this point and look at the measurement of this chord here. Okay, so it's a straight line, not an arc. Okay, so that's one way, maybe measure that, okay? Or I could use the length of the arc length that is spanned by the angle, or the, okay? And that's going to be the way we're going to use in this course, and that's the one that's most often chosen, okay? The radian, this arc length, and that's going to be related to the concept of radians. Now, you realize that if this circle has a radius of 2 or of 3, that's going to change the length of the arc, okay? And therefore, the measurement of my angle, which is not good. I don't want my angle to change in measure if I consider a smaller circle, for instance. Okay, I'd like this angle to be the same no matter what the circle I use. So to avoid this problem, we're going to divide the length of the arc by the value of the radius of the circle. And this ratio will remain the same no matter which circle I choose. So to give you an example, okay, let's look again at a circle of radius r. Okay, and what I'd like to look at is a full rotation. So would be the equivalent of 360 degrees in this case? Well, a full rotation, if I look at the length of the arc, it's just the circumference of the circle. Okay, so if I take the circumference, okay, which is 2 pi r, and I divide it. Remember, I want to divide this by r so that this measurement will be the same no matter which circle I choose, independently of the radius chosen. So if I divide this by r, notice that I get this nice constant that's independent of r. Okay, so that will be the measurement of a 360 degree rotation. Okay, if I want a 90-degree rotation, okay, it would be 1/4 of a circle. 1/4 in terms of the arc, it would be 1/4 of the circumference. So it would be what, 2 pi r divided by 4, and that I divide by r. Okay, I divide by r again just to make sure that my measurement is independent of the radius chosen, and that's going to give me pi over 2. Okay, so here we would call this an angle of pi over 2. Now there are no units right now, but we'll introduce the units very soon. So this is an angle of 2 pi. Okay, now what would be an angle of 1? Okay, so what would be an angle of 1? Okay, well, if you think about it, okay, it would be an arc, okay, such that, okay, the length of the arc, okay, over r must be equal to 1. In other words, L must be equal to the radius. So if this is r, this is r, L must be equal to r. So an angle of measurement 1 for our new system, okay, this is an angle of 1, would be such that the arc subtended by the angle will have a length of r. So because of this, because when the angle is 1, it's equivalent to an arc of length r, we will not say it's an angle of 1 radius, because we don't want to use radius again. We'll say it's an angle of 1 radian. So this is 1 radian, like that. Okay, and coming back to the other angles here, 2 pi, okay, will be 2 pi radians will be the angle corresponding to 360 degrees. And pi over 2 radians will be the angle corresponding to 90 degrees. Now 2 pi, if you calculate it using your calculator, this is about 6.28 something. So that means when you go around a circle, of radius r, you go about 6.28 times the radius. So that's why we say it's 6.28 radians. Okay. So to summarize what we've done here, okay, this is how we measure angles now. To measure an angle, we calculate the length of an arc, of a circle, okay, spanned by the angle, and divide it by r. Okay, or by the radius. Okay, that works if you go 2 rotations around the circle also. Like if you go 1 and 2, okay, that would be 2 pi r times 2, okay, divided by r. So that would be 4 pi radians. So say this is an angle, so maybe I should have used a different color here. Let me do that. 1 and 2. This is 4 pi radian. So an even multiple of pi is going to be a rotation corresponding to 1, 2, 3, 4, 5, or 6 rotations around the circle. Now if we use the unit circle, okay, instead of an arbitrary circle, in this case, the difference is that the radius is going to be 1, so you won't have to divide by the radius because the radius is 1 already. So the measurement of the arc will correspond to the measurement of the angle. Okay. So on the unit circle, the measurement in radians, of course, of the angle is the measurement of the arc length. Okay, so to be precise, so for example, let's say this is the unit circle. So it goes through 1, 0 and 0, 1. Okay, I'll remind you what the equation of that circle is. It's this. Okay, and if I look at 1 radian, okay, 1 radian is when this arc length is of 1. So it's roughly 57 degrees, by the way. Okay, so this is when this is 1, this is 1, and this is 1. So this is 1 radian right there. Okay. How do I know, by the way, that it's 57 degrees? That's a good question. You can use a rule of thumb to figure that out. So, for example, you could say like 1 radian divided by 2 pi radian is in the same ratio as the angle theta in degrees divided by 360 degrees, right? Because 2 pi radians is 360 degrees. So the ratio of 1 radian to 2 pi should correspond to the same ratio as the angle in degrees to 360 degrees. So if we solve for theta, we get that theta is 360 degrees times 1 over 2 pi. So it's 360 divided by 2 pi. Okay, and if you calculate this, if I'm not mistaken, it's going to give you 50 somehow like 50. Yeah, it's 57.296 degrees. Okay, so this is what 1 radian is equal to, is roughly 57.296 degrees, like that. So that's why I know that definitely it's in the first quadrant. Okay, and then we can figure out like what other angles are in radians. So for example, 30 degrees. What is that? Well, you use that same rule of thumb. So 30 degrees over 360 degrees will be theta over 2 pi. Same ratio. So what's theta? Theta is going to be 2 pi times 30 over 360 degrees. So now the difference is that we're calculating something in radians now, right? This is in radians. So we're calculating the angle, corresponding angle in radians. So that's going to give you what? We can simplify this quite. So 30 over 360, right? That's 1/12. So 2 pi over 2 over 12 is 1 over 6. So this is pi over 6 radians. Okay. If you want 60 degrees, well, it's going to be twice that value. So it's going to be 2 times pi over 6. Okay, because it's 30 degrees is pi over 6, then 60 is going to be twice that value. So it's going to be pi over 3 radians. Okay. We also know that 90 degrees, well, that's that one you can well, you could do two different things. You could take 30 degrees and multiply it by 3. So pi over 6 radians multiplied by 3. Could do that. 3 times 30 degrees, right? So 90 degrees is 3 times 30 degrees. That's 3 times pi over 6 radians. We say rad sometimes, just rad. So that's going to be pi over 2 radians. But it's also, you can also think of it as a quarter of a circle. So pi over 2. Okay, that's another way of looking at it. And maybe another one that's famous is 45 degrees. 45 degrees, maybe the easiest way is it's 1/8 of a circle, right? So this is 1/8 of a circle, so it's going to be 2 pi divided by 8. But again, you can use a rule of thumb and get the same result. So you're going to get pi over 4 radians. Okay, so those are the most famous angles to know. And we're going to see in the next video something that summarizes all of that onto one single picture.